Hello, Namaste. We were discussing the molecular orbital theory and we have seen some initial part of this topic, that is the various terms such as what is the atomic orbital, molecular orbital, etc., up to various roles for filling of the electrons in the molecular orbitals, the Schrödinger's equation, etc. So we have seen number of concepts, that is what is sigma bond, sigma symmetry, pi symmetry, delta symmetry, etc. Now we will see the homo-nuclear diatomic molecules according to molecular orbital theory. And for this purpose, we must know what are the first two terms. That is, what is magnetism, that is paramagnetism. Paramagnetism. So, paramagnetism is a behavior of a substance when we place the substance in magnetic field, and if it shows attraction towards the applied magnetic field or that magnetic field, then it shows, we say that it shows paramagnetism. So this behavior appears because of the presence of unpaired electrons in the substance, and because of these unpaired electrons, the substance is attracted towards the magnetic field or magnet. Therefore, the substance is called paramagnetic and the phenomenon is called paramagnetism. Then, if we see, the substance is not containing any unpaired electron, means every electron, whatever the electrons are there in the substance are all in paired state, then such substance is not attracted towards the magnetic field, and therefore such substance is called diamagnetic, and the phenomenon is called diamagnetism. Diamagnetism. So these phenomena are included in properties of the substance. It is important because the Lewis dot structure is not capable to explain every molecule for their appearance of magnetic characters, such as the B2 molecule and oxygen molecule, which are experimentally proved to be paramagnetic, but these are said according to Lewis structure to be diamagnetic. So this distinction can be explained very well with the help of this molecular orbital theory. Again, we found that as we go or move from lithium to neon, we find that the atomic number increases. Similarly, the nuclear force of attraction exerted on the valence electrons also increases. As a result of this increased attractive force on the valence electrons, the valence electrons are pulled more closer to the nucleus. As a result of this, the molecular orbitals show decrease in their energy, and this decrease in energy is found to be progressively as we move from lithium to neon. Then we will see how this actually is shown in this diagram. Now we will show that this is this energy axis. So this is energy axis, and we will show that the molecular orbitals which are present here are shown here. So first of all, we will show this sigma. So we will show this sigma G to S. Then we will have sigma star U to S. Then we will have this pi U to P Z. Pi U to P. There are two such orbitals, pi U to Py and pi U to Px orbitals. Then we will have this sigma G to P. Then we have pi g star 2p orbitals, and finally we will have this sigma u star 2pz. So this is 2pz. So this is the energy space you will find here. So these energy levels of sigma are lowering energy axis, and the energies of these remaining are higher. Now we will show these in case of different molecules. So when we consider here the molecules like say Lit, then there is Be2, then B2, then there is C2, then there is N2, then there is O2, and next is F2, and last is Ne2. So we will have such molecules as we move from lithium to neon. So their atomic numbers means Z is equal to, you will find that 1, here are 3, Z is equal to 3, 4, 5, 6, 7, 8, 9 and 10. That means atomic number. Then we will have these orbitals we here like this. If we take lithium, it will have this sigma g 2s, then it will have sigma u star, then there are these two orbitals of pi nature, pi u 2p, then there is sigma g. So we will show it with different color like this. So this is sigma g of 2pz. Then there are these pi orbitals like this, and this is sigma u star, that is antibody molecular orbitals. Now we will have electrons available for distribution in these orbitals. So each lithium atom provides one electron. So there are two lithiums, so they will provide totally 2 electrons. And according to above principle, Wolf's law of maximum multiplicity, Pauli's exclusion principle, etc. So these electrons are distributed here, and these 2 electrons will enter into sigma g, that is 2s. Then we will have the next Be2 molecule, which is having energy level like this. So there is decreasing energy like this. So they will show decreasing energy. Like this. So compared to each, so these are the molecular orbitals. So if you compare the energy levels of these molecular orbitals and energy levels of these molecular orbitals, you will find that compared to these molecular orbitals are lying at relatively lower energy level. This is because of the increase in nuclear charge as we move from lithium to neon. Then if we try to distribute the 2 electrons, so compared to this, there are 2 more electrons which are entering into these molecular orbitals. So there are already 2 electrons in this way, and next the 2 electrons are going into sigma u star 2s. Again, we will have the molecular orbitals for B2. So we can show these B2 like this. Like this. Now we can show, compared to this, 2 electrons are more to be filled in these orbitals. So we can distribute these 2 electrons like this, and 2 more electrons will enter according to Soul. So the pi molecular orbitals of bonding nature will contain one electron each, and therefore it shows magnetic behavior. Now, the carbon will show the same behavior like this. So we have here C2 leads to, again there are these two, again we will have these two and these two, like this. Now if we, again there are two more electrons to be distributed here in these molecular orbitals. So the electronic configuration will be like this. Now we will have these next molecule like this, and the electron distribution in the molecular orbitals having these energy levels are like this. And there are again increase in two more electrons in N2. So we are showing these electrons in this way. So two more electrons will go into these molecular orbitals like this. Now in case of oxygen, we have these energy levels like this. Like this, and this will have again two more electrons for distribution. So we have the number of electrons like this. So then two more electrons will enter with same spin in the pi anti-bonding molecular orbitals. Now we will have F2 like this. So the two more electrons will be added with this way. So we have a here one more orbital. Like this. Then last element neon. In each molecule we have energy levels like this. So this will have distribution of electrons like this. Like this. So this is about the electronic configuration. So here you will find that as we move from this lithium to neon, the energy levels are found to be decreasing, and up to this N2 the sequence is same. where pi molecular orbitals are low lying and sigma molecular orbital is higher in energy. But as we move to oxygen, there is inversion, means the pi molecular orbitals are going up and sigma g is coming down, means lowering in energy. So we can show this with crossover. So we can indicate this as a crossover. So you will find that there is such type of crossover. So there is change in level. So in oxygen, the sigma g orbitals are at higher level. But as we move to oxygen, it goes down and pi molecular orbitals are coming up in energy axis. So if we see the bond order, then you will find that the bond order is like this. So we will show this bond order here. Bond order. So here you will find that there is only one electron pair. So the bond order is 1. Here there are 2 electron pairs. So the bond is 0, means bonding, anti-bonding. So we have to see that there is 0 bond order. In such a molecule does not exist. Again here this bonding effect is cancelled by this bonding effect, and these two will give us the bond order 1. Means 2 unpaired electrons will give bond order totally 1. C2 will have the bonding effect, this is cancelled by this, and these will give us 2 bond order 2. In case of nitrogen, the bonding effect of this is cancelled by this, and these are bonding electrons. So this nitrogen will have bond order 3. Oxygen, you will find that the enol, so the bonding effect is cancelled, this bonding effect is cancelled by this, and there it shows this bonding electron shows formation of 3 bonds, but out of these 1 bond is cancelled because the 2 electrons are present in antibonding molecular orbital of pi nature. As a result of this, there are only we have 2 bond order 2. So the bond order is here 2. Bond order is 2, and in case of this, the bond order is 1, and in this case the bond order is 0. So on the basis of bond order, we find that nitrogen has triple bond, carbon has double bond, this B2 has single bond, Be2 has no bond, lithium has 1 bond, oxygen has double bond, H2 has a single bond, and Na2 has 0 bond. Means molecule is monoatomic. Here also molecule is monoatomic. So the existence is different. So that we will discuss in the next lecture in detail in case of each molecule which we have seen here. So we will stop our discussion here. Please subscribe to this channel and press like button and this bell icon. So thank you very much for watching this. Thank you.